So for today's deep dive, we're not just, reading off a spec sheet. We're going to really try and tear down the DBX1231V dual channel equalizer. Our mission is to figure out why this specific piece of gear has become, well, such a default choice for serious installers.
It really is the textbook definition of pro audio processing, isn't it? I mean, it's made by Harman. You've got the dual channels, 31 bands per channel, and those are all on the standardized ISO frequencies. So its whole identity is about surgical accuracy, that, and just absolute survivability in a permanent install.
Okay, let's unpack that. Let's start with how you actually interact with it. They use these big 45mm faders. Why is that extra physical travel so important?
That length gives you direct tactile control. It's surgical. Think about it. If you're trying to dial out a very specific feedback frequency in a huge venue, say at 3.15 kilohertz, a single millimeter of travel on that fader can be the difference between a clean show and, a horrible howl. That kind of precision is just, it's non-negotiable.
Right, and that leads directly to maybe its most standout feature.
The selectable ranges.
Exactly. The choice between a really subtle 60 dB range or a much more aggressive 15 dB. What's the thinking behind giving you that choice?
It's all about flexibility. That 6 dB range is perfect for, say, fine-tuning a studio playback system. Very transparent. But if you're doing live sound, or you're trying to fix an old problematic system that needs some heavy lifting, or you're notching out deep feedback, you absolutely need that 15 dB of authority. It's like having two different tools in one box.
But all that precise EQ work doesn't mean much if your signal is noisy from the start. How does this thing clean up the signal before it even hits those 31 bands? I'm looking at this 18 dB per octave 40 Hertz low-cut filter. Why that specific filter type, a Bessel?
That filter is it's essential for system integrity. An 18 dB per octave slope is incredibly steep. It's designed to aggressively strip out useless energy, things like air conditioning rumble, stage vibrations, mic handling noise. And the steepness is key because it protects your amps and speakers without, messing with the frequencies right next to it. It preserves that low-end musical clarity.
Okay, let's switch to connectivity because this unit just screams permanent install.
Yeah.
You got your standard XLR and quarter-inch TRS, sure, but also barrier strips. Why does a pro piece of gear need 3 different kinds of I/O?
It's because installation standards are so diverse. XLR and TRS, that's standard for mobile racks and patch bays. But the barrier strip is the go-to for long, fixed wire runs, especially when you're integrating into a larger system, like in a broadcast facility or a house of worship. It's built to talk to everything.
And speaking of installation, the design seems almost obsessed with fighting noise. You've got RF filtered inputs and outputs, a chassis ground lift, and a magnetically isolated power supply. Is that level of isolation really necessary? Or is it more of a premium, nice-to-have feature?
Oh, it's absolutely mission critical. That isolated power supply is like a moat around the audio circuits. It makes sure that no matter what else is happening in the rack, power hum doesn't bleed into your audio path.
And the ground lift.
That's the installer's panic button. It can solve a nasty hum loop in seconds without having to rewire anything. The RF filtering is just another layer, dealing with things like cell phones or wireless gear.
And for reliability, there's a power-off hardwire relay bypass with a 2-second delay on power-up. What does that do for system safety?
It's pure protection. The hardwire bypass means that if the EQ ever loses power, the signal just passes straight through, clean. Your show doesn't stop. And that 2-second delay, that prevents that horrible speaker-killing thump when the unit turns on. It protects everything downstream. It's built to survive.
So if we boil it down to the performance metrics, the actual numbers, how do they translate all this engineering into sound quality you can hear?
The specs basically guarantee transparency. We're talking about total harmonic distortion plus noise of less than 0.005%, which means you can apply really heavy EQ correction without introducing any electronic sound from the unit itself. You're only hearing your choices, not the circuit board.
And I'm seeing a signal-to-noise ratio up to 97 dB and a dynamic range of up to 115 dB. So you're basically getting silence from the electronics themselves.
Precisely. Those numbers just confirm this thing will sit in a rack for a decade and maintain an incredibly clean signal, even in the quietest moments. And it's all housed in that tough 3U steel and aluminum chassis. It's just built to last without any maintenance.
So to wrap up our deep dive, the DBX1231V is really about pairing that surgical 31-band control with what you could call mission-critical robustness. It's all designed for the toughest installation environments.
Yeah, which brings up a really interesting final thought for you to consider. When you think about the fact that this requires a barrier strip connection alongside the standard XLR and TRS, How does that one detail, that versatile standardized connectivity, really illustrate the deep difference between gear design for, say, a simple touring rack and equipment that's engineered from the ground up to be integrated into massive, complex infrastructures like a theater or a broadcast facility? It's a whole different world of thinking.